Hello, everyone, and welcome back. Welcome to Unit 4 of Grade 9 D-Stream Math. Today, we are going to be reviewing some angle properties and angle laws regarding different types of angles and also regarding triangles as well. So I know a lot of this is probably review, but I do want to briefly go through it. If we have a corner angle or a right angle, we know that every right angle is 90 degrees. So whenever we see this symbol here, this little square, we know that the total is 90 degrees. So that means that if we add up two angles in that, they're going to be equal to 90 degrees. And now what does that mean? That means if we know one angle, we can find the other, right? We can easily find another. As long as we have A or B, we can find the other one very easily. Now, what about the second angle theorem, straight line angle theorem? Well, here, if we have a straight angle, then the straight angle is 180 degrees, so that means A plus B in this case would be 180 degrees. And so if we know A or B, we can figure out the other one simply. And then 3 is opposite angle theorem. So this is basically saying when we have opposite angles, that these two angles here are the same. And also, these two angles here are the same as each other. Now, that doesn't mean that all four angles are necessarily the same. In fact, they're probably not, but these two sets of angles are the same. So here's some quick examples they gave. They said over here for A, we have a straight angle. We know that this part is 120. So what must the other part be? The other part must be 60 because together they must add up to 180. Same thing with B. They said, well, these two angles together, 53 plus x, must be 90 degrees. So therefore, x must be 37, right? Because 53 is already part of it. So there's 37 left to get to 90. Then we have C is 105, right? So for this one, we can use a couple of different ones. We can say, well, because of our opposite angle theorem, that means if this is 105, y is also 105. And then by our straight angle theorem, right, with this straight angle, we can say, well, if that's 105, y must be 75 because x plus y must be 180, right? And then for D, they do the same kind of thing. They say they use opposite angle theorem to say that that x must be 30 degrees because the opposite to x is 30 degrees. And therefore, y must be 60 degrees because x plus y in this case, it looks like it's that square angle, that right angle, must be 90 degrees. So pretty straightforward. If this is not a review for you, if this is new, there are other resources I can recommend for from learning this from scratch. But I do imagine for most people, this is probably things you already know, and we're just kind of reviewing them briefly. Next, I want to briefly talk about angles inside a triangle. So whatever type of triangle we have, all the angles added together are always 180. So if we ever know any two angles in a triangle, we can easily find the third one because we know that all three angles added together are going to equal to 180. Now, there's three types of triangles, and this angle sum theorem for triangles exists within all of them. Okay, but let's review the different types of triangles briefly too. Here we have equilateral. So with an equilateral triangle, all sides are equal and all angles are equal. And by extension of that, if all angles are equal, well, we know the three angles must add up to 180, so they must each be 60 if we are to divide 180 evenly amongst these three angles, we get 60 per angle. Then we have isosceles, and this is where two sides are the same, and therefore two angles are also the same. And then we have scalene, where no sides are equal, and therefore no angles are equal either. So here they have some examples of how we can use our angle theorem for this. We can say, well, we have 84 and 35 and x, and we need to find x. How do we do that? Well, we know that x plus 84 plus 35, x plus the other two angles, has to add up to 180, right? And so we can easily solve and find that it's 61. Same with B. We know this square angle is 90 degrees, and we have 38 degrees for this second angle here. So we can find out that x would be 52 degrees, right? So again, with this stuff, I do hope this is review from middle school or even maybe some of it from elementary school as well. But I did want to briefly touch on it because having this foundation is going to be important for what we'll discuss next in this course. So we're going to go over some more examples. I think there's 18 examples here. A lot of these examples, I do want to mention, are examples that will probably be very simple for you, but do watch till the end today because some of the later examples are more challenging. They do get a little bit more challenging. Or if you want to skip ahead to the end and see, that also works as well. Here they just do a brief review of how the angles in a triangle, so the angle sum theorem, the opposite angle theorem, the complementary angle theorem, which is, where we have our right angle and they must be 90 degrees, and then the supplementary angle, which is just where we have a straight angle and we know that the two angles within must add up to 180. All right. So let's solve for the missing angle. So for this one, how would we solve it? Well, we know that this right angle has to add up to 90 degrees. So to find the missing angle, we do 90 degrees minus 33 degrees, and that gives us 57 degrees. So the answer is 57 degrees. This one is a straight angle, right? So that means 180 is our total. Minus 67 should get us our answer. So that would mean it would be 113 degrees. So there we go. As for number 3, we know that opposite angles are the same. So x would also be 121 degrees. Same thing with number 4, very, very similar kind of question where we just have the opposite angle, must be 37 degrees as well because that's what the original angle is. So there we go. Then we have number 5. We know that all of these together must add up to 180. So if we do 180 minus 102 minus 39, we can get the value for k degrees. So let's do that. 180 minus 102 minus 39 is equal to 39 as well. So therefore k is also 39. And it turns out this is an isosceles triangle. Okay. Let's do number 6, where we have 180 minus 90, right? Because the right angle is 90 minus 36. Good. Okay. Then we have number 7, where we have angle ABC is 58 degrees. And then we have angle CBD, which is 37 degrees. And then we have DBE, which is 59 degrees. Find ABE. So they want us to find this one. So this was actually something we didn't discuss yet today, but I want to remind everyone that the whole full angle that goes all the way around adds up to 360 degrees. So to find the answer here, we must do 360 degrees minus 58 degrees minus 37 degrees minus 59 degrees, and that'll get us the answer. And it looks like this is just going to be slightly over 180 just by kind of eyeballing it. So let's make sure that our answer lines up with that and that it looks like it's approximately just a bit more than 180. So if we plug those numbers in, we get 206. So that's good. That's just a little more than 180. Now keep in mind these pictures aren't always exactly to scale, okay? So I wouldn't count on, measuring them with a protractor or anything like that. That's not the point of these exercises. But also, if you get some, angle that just doesn't even look remotely like what it should be, that's an indicator that there might have been an error made there. Good. All right. Let's move to number 8. Number 8 says angle ABF is 170. So they're saying this whole thing is 170 degrees. They're saying ABC, this part is 21 degrees. Then they're saying DBE is 19 degrees. Then they're saying EBF is 23 degrees. So what is CBD? Okay. So CBD is going to be 170 degrees, right? That's the whole thing, minus the other angle. So minus 21 degrees, minus 19 degrees, minus 23 degrees, okay? And do keep in mind, CBD does look like a really big angle, right? All right, so 170 minus 21 minus 19 minus 23 is 107 degrees, which does seem like that's a pretty big portion of the 170, but that is okay because, if we look at this angle compared to the other angles, it does look like it should be a lot bigger, right, to account for a lot more of that space there. Very good. Let's move on to number 9. Here, number 9, they want us to solve for x. And here we have that these are opposite angles. So that means they must be equal. So that means x plus 45 must be equal to 2x minus 19. Now let's solve this equation. We need to add 19 to both sides to get x plus 64 is equal to 2x. Then we must subtract x from both sides to get that x is equal to 64. So x is 64 in this case. Very good. Okay, let's move on to this one. Here we have x and 3x plus 18 as our two parts, and we need to solve for x. So how do we do that? Well, we know that these two together must add up to 90 degrees, right? So that means we must have 3x plus 18 plus x is equal to 90 degrees, right? So that means 4x plus 18 is equal to 90, which means 4x is equal to 72 if we subtract 18 from both sides. And then that means x is equal to 18. Very good. Okay. Then we have 2x plus 8 and x minus 24. Okay. So let's do it. 2x plus 8 plus x minus 24 must be equal to 180 because this full thing is a straight angle. So let's keep that in mind. The full thing is a straight angle. So then we have 3x, and then let's see, what's 8 minus 24? 8 minus 24 is negative 16. So 3x minus 16 equals 180. Then we add 16 to both. We get 196. So x is equal to 65. There we go. Okay. Let's try this one. This is a isosceles triangle. And what does that mean? Well, since we have two sides the same, that means we have two angles the same. So that means these two angles must be the same thing, which means we can use one of our equations to solve this. We can say, well, we know that the three angles add up to 180. So that means 120 plus A is equal to 180, which means that 2A is equal to 60, which means A is equal to 30. So there we go. There we have it. All right, for this one, to solve for x, we know that opposite angles are the same, and therefore 2x minus 17 must be equal to x plus 12. So therefore, if we subtract x from both sides, and we add 17 to both sides, we will get x is equal to 29. And there we go. And 14 is similar to 12, where we know that these two angles must be the same, right? And we know one of them is 38 degrees, so the other must be 38 degrees. Now, how do we know that? We know that because this is an isosceles triangle. These lines indicate to us that these two are the same thing, right? These two are the same thing. And so we're good. So how do we do this? We know that x plus 38 plus 38 is equal to 180, right? Because all three of them together are 180. So we have 76. So that means x plus 76 is 180. And that means x is equal to 104. So there we go. Okay. Let's move on to 15. Well, for 15, we know that this angle and this angle must be the same, right? Sorry, not must be the same. They must add up to 180 degrees. So let's solve for x this way. We know that x plus 58 plus x plus 21 is equal to 180 degrees, which means that 2x plus 79 is equal to 180 degrees, which means 2x is equal to 101, or that x is equal to 50.5 in this situation. Good. How about for this one? We know that these two angles together must equal to 180. So that means x plus 2x is equal to 180, which means 3x is equal to 180, which means x is equal to 60. Very good. Okay, let's move on to number 17. For this one, we know that all three angles must add up to 180. So that means 5z plus 2 plus 118 plus 15 is equal to 180. So that means we have 120, 135, 5z plus 135 is equal to 180. And that means 5z, if we subtract 135 from both sides, that we have 5z is equal to 45, which means z is equal to 9. Very good. Okay, and let's move on to 18, which is our last one. So same kind of thing again. We know that all three angles, so 5x plus 3 plus 37 plus 85, is equal to 180. So that means that 40 plus 85 is 125, right? So we have 5x plus 125 is equal to 180. And 180 minus 125 is 55, so 5x equals to 55, which means x would be 11. And there we have it. Very good. Okay, so that is all of those questions, and this is the only kind of main review day for this unit. So do make sure that all of this made good sense before moving forward. And if it didn't, then that's okay. I can share some other resources that will help get you up to speed. But this is kind of our review day to kind of get into the actual grade 9 material. So next day, we're going to start the grade 9 material now that we've kind of done a review of the angle laws and theorems that hopefully you've learned in grade 7 and grade 8, and perhaps before then some of it as well. And yeah, we will see everyone next day. Good work today, everyone, and bye for now.